Good morning, everyone. Welcome to another webinar on the Creo product. My name is Thiagu Palaniappan. Work for TriStar, and TriStar being the largest reseller for PTC products in North America. So today's topic is going to be on the computer-aided engineering solutions or the simulation analysis solutions within the PTC Creo product suite. Before we go through the agenda, I just want to quickly go over some of the offers that we're running through the end of June on the Creo Simulation and Analysis products, and also on PTC certified training. It can be on-site or virtual training. This is also going to be running through the end of June. Also on MathCAD, right? For calculations, you can embed a MathCAD worksheet within Creo Parametric, starting Creo 3.0. So there is going to be a promotion on that as well. So please reach out to your account reps at TriStar if you need additional information about these three offers. And just want to remind about the PTC LiveWorks event that's happening in June 6th in Boston. Our PLM team will be there to help you with any questions. So there's a website, you have information about the registration and the event details. So that said, today, mainly we have covered Creo Simulate in the past, but I wanted to just go over, other than Creo Simulate, also cover mechanism dynamics, behavioral modeling, and tolerance analysis extension, right? So there are quite a lot of tools available in Creo on the computer-aided engineering side, right? Once you're done with your CAD model, it's very important that you start engineering the product, right? So not just testing the performance, but also maybe you might have a mechanism, or you might have a part that you need to do some design iterations for optimization, right? Or you might want to just do a quick tolerance stack-up analysis, right? So those are the things that I'm planning to cover in the next 30 minutes or so. And as usual, all of you are muted right now, but there will be a Q&A session towards the end. So please feel free to start typing in your questions on the chat session or in the questions section of your GoToWebinar window. And I'll try my best to answer all the questions towards the end. So here's, before I talk about those four tools on the simulation side or on the analysis side, just a quick, this is from Aberdeen Research. You can see there's some metrics on the cost savings, when you do simulation up front rather than after the design. So it's simulation, that's something that should be coupled along with your design process, right? And how much amount of cost savings, warranty costs, and the amount of ECOs, and the time that you spend to do these, you could see it's a huge benefit when you have a simulation solution and you're trying to couple that right from the beginning of your design, right? You just want to couple that rather than doing it after, right? So currently, this is just a quick overview. What you're seeing is the CAE landscape, if you will, of Creo Parametric, right? So when I say CAE, I'm talking about computer-aided engineering. So you take the CAD model, parts or assemblies, and within Creo Parametric, it's all integrated. You're either able to run a structural analysis, a thermal analyses. You might be able to do even durability studies using Fatigue Advisor, or maybe you want to place a mannequin and do a analysis, a human factor analysis using the mannequin. Or maybe you just have a dynamic assembly and moving bodies and stationary bodies, and you're interested in the force calculations and the reaction forces that you might want to export into Creo Simulate. But to get those forces, you can use the dynamics option within Creo. Sometimes you might just be interested in kinematics, or sometimes you're interested in dynamics. So depending on the use case, right, there are different options available within Creo. And also, like I said earlier, MathCAD worksheets can be embedded to your Creo model. So let's say you really have a complex formula, or you have a calculation that you would like to drive your Creo model. So input, output from external sources like an Excel spreadsheet or a MathCAD worksheet is also possible within Creo Parametric. and also tolerance analyses, right? So that's something that we have seen. We all use homegrown spreadsheets, what have you, right, for doing your stack-up tolerancing. So within Creo, there is a tolerance analysis extension that allows you to do 1D stack-up analysis with worst case and statistical analysis. And it's going to give you a report. So the next time when you are going to give a tight tolerance, you can tell to manufacturing, hey, this is why, right? You're able to give them a proof of why you're giving a tight tolerance, or what is the defective parts per million unit, etc. Right? So if I were to list all the different simulation and analysis solutions available right now as of Creo 3.0 within PTC's product suite are obviously MathCAD engineering solutions doing 1D tolerance stack-up analysis, right? Doing optimizations and sensitivity analysis on your designs using behavioral modeling extension, right? And then there's mechanism. Some of these are built into the base package, like doing kinematics. But if you're interested in force calculations, right, you're getting into the dynamic analysis. That's when there's some additional extensions on there. And then you can, check the structural integrity or the performance of your product. Also simulate thermal conduction, convection, radiation, heat transfer, or fatigue analysis for durability. You're essentially checking for an endurance limit, and you want to know if there's a crack that might form within that endurance or within that cycle that you apply the load. Also modal analysis, right? You want to know the natural frequency and the mode shapes. Spark analysis for electrical spark analysis, if there's a light module and a full module on that. And also human factor analyses, right? So that's when you can place a mannequin. You have different postures, right? You can see the view cone, and you can just really checking for ergonomics, really, right? So that's a human factor analysis using mannequin extension and mannequin analysis extension. And also the mold filling process. That's more from a manufacturing perspective. I would like to see the plastic injection mold filling process. Is there any air trap vents? Is there any red flags that I should know ahead of time on my design? That's something that it allows you to know. Used to be called Plastic Advisor previously, and PTC now it's changed to partners on there, and now it's mold flow analysis. So that's kind of like a quick listing. Some of you may need some of these, some of you may have already be using it, but just a quick overview of all the computer-aided analysis solutions that we have as of today within Creo Parametric, right? Now, if I were to take the first one, which is obviously Creo Simulate, many of you may have used it or currently using it. It's the structural and thermal simulation tool within Creo Parametric. It works, can work independently of Creo, or it can work in integrated mode of Creo. And the good thing is you're not just simply analyzing for stresses and deformations and frequencies and temperature. You're also able to optimize your design based on some analysis goals, right? I want to make sure the deflection and the stress is less than certain values, and here are my design dimensions, and here's my range. And the software allows you to do design exploration, or I should say design optimization, since it's linked to Creo Parametric. It's easy to use, obviously. It's fully integrated to Creo, so it's the same ribbon UI that you're all have gotten used to. And also, it's accurate, right? It uses the P-level algorithm to automatically bump up the polynomials to give you accurate results when you run Simulate using the multi-pass adaptive solution that's built into the solver. A quick snapshot here on the comparison between the different packages that you have, that PTC has. If you have Creo Essentials Premium, you already own some basic capability wherein you can do static analyses on parts and assemblies, including meshing and the ability to do report. But then if you want to get into design optimization, do some thermal analysis, get into idealizations, and that's when you need the full Simulate extension. And if you want to go beyond that, get into vibration analysis, nonlinear analyses, and contact analysis, that's when you would need an advanced Simulate extension. So like I said, the Essentials Premium comes with some basic capabilities. If you're just doing pretty straightforward static analysis, this tool should do it for you. Or if you're looking a little more capability than that, then it would be Simulate extension that gets you modal analysis to check the natural frequency and the mode shapes. Or you can do a buckling analysis wherein you're essentially applying a compressive load and want to check what is the maximum load at which my structure will buckle, right? Or you want to just do steady-state thermal analysis. And sometimes your assemblies are so complex that rather than running the model as is, I would like to use some idealizations or mathematical approximations where my entire engine assembly, I don't care about the stress on that. I just want to include the weight of it, so I could just approximate as a mass element. Or I have a component that just imparts stiffness to my geometry or to my analysis model. I could just use that as a spring. Or if you have huge structures, right, you could just use beam idealizations. And all these are computationally less expensive compared to the actual CAD model that you may have, right? So that's when you would need the Simulate extension. And the advanced Simulate extension obviously gets into some of the nonlinear capabilities that PT's introduced as of Wildfire 5 and Creo, with large deformation, contact, right? Also plasticity, what happens when I go beyond yield, like in that stapler pen example that you see in the image. That's got into plastic deformation where even if I remove the load, it's going to still stay deformed, right? Maybe I'm interested in that, and I would like to know, does it hit ultimate stress, going to fully break? So those type of advanced analysis is covered under advanced Simulate extension, including transient thermal analysis. And you have a few advanced mapping options when you get into advanced analysis or nonlinear analysis. Obviously, you do need some better control on the mesh that's available, like mapped meshing is available in the advanced Simulate extension. And then if you're doing a durability study on your design, so I have my assembly or part where a single application of the load, obviously the stress is well below yield. However, if I apply it 1,000,000 times, in how many cycles, right, is there a chance of a crack to start, right? We're not getting into the crack mechanics or the crack growth, but all you might be interested to know is give me the confidence of life, or let me know if a crack might start within a certain number of cycles, and it's going to inform you that, right? So like in a plot, right? For the most part, it looks like gray, but then there's like certain red areas where I might have to go and optimize my geometry or make it stronger, so I don't get that. I don't get it. You know, I'm not allowing the crack to initiate at that location. And then mechanism dynamics. So this is the second tool that I was talking about, which is typically called MDO. There is a mechanism that's already built in to the Creo parametric that you currently own. If you have an assembly, you're already able to use connections, right, when you apply constraints, and that allows you to create kinematic assemblies wherein all you're worried about is just the motion, right? You don't care about forces, you don't care about gravity, you don't care about external loads or reaction forces. That's the kinematic side. What is also called MDX, or mechanism dynamics extension. But sometimes you might be interested, like in this example, like in that link for that bike example of Santa Cruz, which is one of PTT's customers. You could see how I'm interested to run a stress analysis on that very critical component. However, I'm not sure what different loads it might undergo. Now, this is used for downhill race bike, and it might undergo different terrain, and you could see the different forces that it might be subjected to. And this would be a typical in an example where you might want to run a dynamic analysis first. It's a rigid body motion, right? Wherein you want to apply density, right? You want to apply enable gravity, apply some external loads, and some dynamic entities within mechanism, and get forces, and then export those maximum forces out to Creo Simulate and run a full-fledged static analysis on those for those worst case or maximum force conditions. So as you can see here, within the model tree of Creo parametric, what happens is when you go access mechanism, if you see forces, strings, and dampers, and all the dynamic entities, it means you already have MDO. If you don't see those, if you just see bodies and connections and servo motors, and then analysis, you can only do a kinematic analysis, right? So it's more like just doing a collision detection or creating a movie file of a mechanism, right, for training purposes. You're just checking during your design stage if my link is long enough, is it hitting another component, right? You're just checking the feasibility of the mechanism. But if you want to get into force calculations, you're getting into the dynamic side of things, that's when the mechanism dynamics extension is going to be helpful. So here's a quick comparison between the two as to what you currently might already have versus what comes with the mechanism dynamics option, right? I'll show a quick example at the end of the slide. But so really, like I said, if you just want to create, you're just checking for space planes, create like a trace curve or a motion envelope, right? It's pretty straightforward. You would add your constraints as connections, which is essentially a joint between two parts, right? And once you create the joint, you would just run a kinematic analysis for a certain amount of time. And you can even have the capability of exporting a movie file out of that, right? So, but then you want to go beyond that, like apply dynamic entity like a string, right? For the suspension in that example, there's a string that I applied for the stiffness, or you want to apply an external load, enable gravity, friction, what have you. That's when you would need that mechanism dynamics option. And some of your packages that you currently own, right, they may already have it. You just have to be aware of it. Like I said, the best way to check is if you go to an assembly and go to applications mechanism, it's going to give you all this listing that I have here, right? It's going to give you springs, dampers, forces, initial conditions, things like that, right? That kind of tells you that you already have that dynamics module. So before I move further here, let me switch to Creo. So what I have is Creo Parametric 3.0. And what you're seeing here is an assembly, the same assembly. It's part of a bike, obviously, and you can see my skeleton where I have just a rough skeleton of the bike. But the main critical assembly here is the frame assembly, and I could see the most important part here is that lower link that that as an analyst I would like to do a stress analysis on it. But if you look at my motion and my mechanism here, you see how the entire part is moving, really, if you think about it, right? So in the real world, I'll have to simulate. This is something that's used in downhill race bike, right? So maybe I should be able to apply loads at this end, right, to simulate that. So what I did was, if I go into my mechanism, I applied just to simulate the suspension here, right? So it's connected to the swing mom, the main frame, and the suspension, right? The link is a very important part, critical component here. So if I go and redefine my string, it's not a helically swept string like on the CAD side that you're used to doing for a string. It's a real string that's just a representation, but it has some dynamic entities like stiffness, unstretched length, etc., right? So once I specify that, I'm able to use that in my dynamic analysis, right? I also have a motor. Now it could be a servo motor or a force motor. So wherein I have a certain profile that I've added just to kind of simulate the different terrains that this bike is going to undergo. So that's why I'm giving different positions for that part, so that frame will move up and down right there, and I want to see the effects of these forces on the other side, right, on this component. So when I do a dynamic analysis like this, let's say I want to run this dynamic analysis, see how it's running through that sine wave or through that different position motor that I had applied at the very end. That's my driver, essentially, right? Now, this is good. I got a kinematics out of it, but I would like to get forces out of it, right? So what you could do is you're able to apply reaction forces at these three connection points. So that's what I have here. And I want to see the values of those forces and at those using this analysis. And you see it gives you some values at currently what's the value. However, I want to plot them in a graph. and review them as I'm running the analysis, right? So here's the three colors that you see are the three forces. There's even a way to display it on the graphics window. I'll show in a second here. But when I run the playback, I want the ability to display those three arrows, right? And also, I want to be able to run that. Now, when I run it, so when I'm about to run it, you see the three big arrows that you see there. And let me just resize this. There you go. Okay. So I'm going to run it for a set amount of time, and let me increase the speed here, and I'm going to run it. And I'm not sure how fast it's coming across over the internet here, but you could see, let me zoom in here, that the force vectors, the arrows change size based on the reaction values, right? So for example, I do have a high force, it looks like, so maybe I might want to stop somewhere here, right? So this is where I'm interested. These are the three forces that I'm interested to extract from mechanism dynamics and maybe run a stress analysis using those three forces, right? So what I would do is within mechanism, there's a way to export force systems to simulation, right? That's what I'm doing. So the body and the component to which I want to export it is also the same part. That's the body forces, and you see how it has given me the list of forces. Now I could say I want to go for the single max loads, the maximum loads that I showed you in the graph, and maybe I just want to collect the forces, the main three forces, right? So what I've done is I've exported those forces, and now if I exit mechanism and get to my part, and take it to simulate. As usual, I can apply external loads, but then I can apply the mechanism load, and those three forces, the values, that's critical to me, right? I cannot simply guess on some values or make some hand calculations. That's the key here, right? That's the biggest advantage of using these multiple simulation tools in one integrated solution, right? So I want to import them, and as soon as I import them, you see how it has put in like arrows. You can see how it knows a value. However, it doesn't know where those three forces need to be applied. So I'm just going to go and distribute it on those appropriate surfaces. A simple double click on those. They're very easy to use, right? It's like an edit definition, and I'm just distributing that force on those surfaces. Now, how would we constrain a part like this? It looks like almost the entire part is moving. And is there a way I can use three-point constraint, or I could use inertial relief? When you run a static analysis, yeah, you want to have a constraint, but in this case, for a body that's entirely in motion, you have the option to go inertial relief, which behind the scenes, the software creates opposite body forces, right? So you don't have to apply a constraint, so it prevents rigid body motion. And you could run the analysis, and what you get out of that is like a stress plot, for example. So here it is, right? I have this result window definition already. I already ran the analysis, and you have it, right? So just to give you a quick example of where it's not that always you know the forces and the loads, and you simply run a straightforward static analysis, right? Many times you may have to couple these, right? So. The next analysis solution I want to talk about real quick is the tolerance analysis solution. So this is something that's been there since Wildfire 4.0 actually with PTC. So we all know tolerance stack-up is a huge, it's very important, as you know, right? So you're allowing for the variation, and as design engineers, right, or as mechanical engineers or designers, there's something that's constantly, there's a conflict of interest between engineering and manufacturing, right? Tighter tolerance is higher manufacturing costs, but then for the engineer, right, he wants to save his, the main thing is you always go for a tighter tolerance, and how am I able to, to manufacturing, how can I tell them that, okay, we do need this sort of a tolerance stack up, or right, a tight tolerance here, and my dimensioning scheme. A lot of things comes into picture when we talk about tolerances, right? Currently in Creo, I'm sure you guys have used nominal dimensions. That's what we use, and in the drawing, we show tolerances, right? There are a couple of config options. You can turn on, enable tolerance, and you can display the tolerance, right? but we are really not doing any specific analysis using those. It's just a display in the drawing, right, or in the part. Wouldn't it be nice when you run into those conflict of interest between design and manufacturing as to why you gave so much of a tight tolerance, to kind of back it up with that little Six Sigma probability study or worst case study, and tell them this is why, right? This is why if we were to give a higher or a lower tolerance, how much amount of scrap might end up getting, and what would be the defective parts per million unit when you, in a mass production scenario, right? That's what we want to give them. So it's based on Six Sigma, right? Standard deviation, right? And then it's PTC. Really, what they did was, you might have heard of it, of a company called Sigmetrix. They create a product called CETOL Six Sigma, which they are like the leaders in the tolerance analysis. And they have plugins for all major CAD systems. And PTC partnered with them and got a lightweight of that product, and they're calling it Tolerance Analysis Extension. It's been there since Wildfire 4.0, and it's very easy to use compared to your traditional spreadsheets or manually doing it. You're essentially selecting dimensions from Creo, and as you select dimensions from Creo, it puts in a dimension loop diagram, and you are able to change your tolerance values in real time, and you're able to see the results. So it's very easy to use, and it has, like I said, it supports 1D tolerance. If you want to have advanced 3D tolerance stack-up, then there is like a full-blown CETOL Six Sigma product from Sigmetrix. But so that's kind of a quick overview of what tolerance analysis extension can do. Now, before I move further, let me just give you a quick example on that. So what I have is you see a PCB board, and it's an assembly, and I'm interested, it's like a fit or clearance analysis I want to do here between this. So let's say the scenario, if I were to go to like a side view and show it to you, right? The objective is to determine if it's possible to assemble the PCB into this assembly, right? So I have a pan, I have standoffs, right? So let's say the current assembly process is the bottom screws are to be are supposed to be installed, right, and tightened first, right? And then the plug is snapped into the holes in the PCB, the green part that you see. Then the PCB assembly is placed onto the assembly, right? And then the top screws are inserted and tightened, right? So let's say that's the current assembly process. Now, in order for this to work fine, there should be a minimum gap, as you can imagine, between the plug and the pan, right? The clearance that I've called out there, right? That's important to me, right? So because if we don't have that, this would prevent the ability to insert the screws into the PCB, as you'd imagine, right? So that's something that I'm worried about, and that's something that I want to use Creo Parametric to help me with that, with how much amount of tolerance I'm going to apply, and I want to look at the worst case and the statistical distribution, etc. Right? So first off, right in here, right? It's just like I said, it's fully integrated into Creo, where you do your basic measurements and mass property calculations. That's where you do your tolerance analysis. I'm just doing a tolerance analysis, and like I said, it's powered by CE technology from Sigmetrix. So I'm going to create an analysis, and it comes up with my dimension loop diagram automatically, and I'm starting to specify my critical geometry here, right? So I'm going to say from this surface all the way to this surface, right? So I'm interested in the distance between those two surfaces. As soon as I've selected the two surfaces, you can see how tolerance analysis is putting in there, is it a sort of a dimension loop diagram? So it's more like I have to go far out, get back in, right? And it's giving me even the appropriate dimensions automatically, right? So I could select, if the tolerances were not applied, I could apply it here, but in this example, I had it applied on the dimension side, right? On the Creo side, I went to properties of dimension and applied it. But when I assign it, you see how it creates, I've selected the first, now that's like the location of the hole. So now it's like the basic dimension for the location of the hole right there. So as I select this dimension, you see how it creates a dimension loop diagram for you automatically. And now I want to select the position tolerance on the hole, right? And also, obviously, the diameter of the hole, right? So the hole thin situation here. So I'm going to select the diameter of the hole, and now it's going to ask me, whenever I select the diameter dimension, it's going to ask me, is it going to be a hole or a pin, so it can apply, floating left, right, and all those conditions, right? So let's say I want to select the hole, right? Once I select the hole, the next step is obviously, it's going to ask me for a few more things, right? I can either keep selecting dimensions, or I could say, okay, what about, remember the assembly process, right? They're going to assemble the bottom screw, so I need to account for that. So let me go select the bottom screw. When I select the bottom screw, I have the ability to select the diameter of that screw, right? So there it is, right? I've selected that. Now, once I selected that, I could say, again, it's going to be a pin this time, right? So you can see how it clearly creates on the left here a diagram showing that there's a hole pin situation here. And now I want to select my PCB. And when I select my PCB, obviously I need to select the hole for that PCB, right? There's going to be a tolerance there, and that's going to be a hole. So you can see how it's building with part names, right, clearly defined here. And then I also want to add the location of the hole, right? There's going to be, so that's also going to play an important role. So really, the first two surfaces I picked, I'm just going to reach back to that surface using dimensions, and my dimension loop diagram is done, right, essentially. So let's say I select my hole location. Now it's for the plug dimensions there, right? I want to select that dimension there. And then also when I select the plug, I want the basic dimension for the location of the hole in the plug, right? And once I do that, I also need to select the position tolerance in the plug. Now, as soon as I'm done with it, it says dimension loop complete. So the first two references I picked earlier, those determine my references, and I just use my dimensions in Creo, regular dimensions in Creo. And what I got, as you can see, is like the result, right? It has already calculated the results for me. It's giving me some statistical worst case conditions and sensitivity information, and this is what I applied. Now, if you think about it, in this case, right, I'm really not worried about the upper limit. What would be my goal between the two surfaces would be I could give a limit and say, right, I really don't care about the upper limit, right? I want to make sure there's no interference, so that's the clearance is the main thing. So I'm going to give a 0 value, right, for the minimum, and then a 1 value for the upper limit, and you can see how that has dynamically changed if you look at the worst case condition, right, that's where my worst case condition is, and that's my statistical distribution, right? Now, I can also change, so I'm looking at this, and it shows me that the defective parts per million unit are so much, right, and the yield percent is 81. So this is where I could say, okay, is there something else I should be changing here? Can I change my tolerances, make it tighter? Or if you think about the pan screw interface, right, the way they assemble it, we should allow it to float, right? When I allow it to float, you see how that updates. Or the screw PCB, the way they would assemble the PCB is they would just pull it to the left as far as possible and then assemble it. So I'm going to just left justify that, right? And you can see how that updates my my results, the worst case as well as the statistical distribution, both mapped on top of each other here. And I can also, so I can look at my sensitivity analysis, and it's showing me that the PCB's dimension is the one that contributes to the stack up a lot, right? So you see the D20, D266 dimension there. So I'm going to go to that dimension, and just like that, I'm able to change, make it tighter, or I can change it right there, and I can see how it updates in real time, right? So this is huge compared to the traditional manual process that you might be using for your tolerance stack up, right? Same thing for the next dimension, right? I could go to the, again, there are like some of those PCB dimensions there that I want to change. So maybe I want to set it to, you see how I'm kind of decreasing, you know, in red that you see, right? The ones that will end up being scrapped, right? If you were to create a million unit, that's what it's giving me, right? So you're able to kind of adjust your tolerance values, and so the next time when they ask you, hey, why did you give such a tight tolerance, or, you know, you're able to back it up with such reporting tools. In fact, I can quickly create a report out of it, and there you go, right? So I have a report of your tolerance stack up with the dimension loop diagram and everything. So So you see that, and I really did it quickly, as you can see here, right? With all you really, and if you didn't have your dimension with tolerances in Creo, you could do it later also, right? It's not that you have to have it done earlier. You can even add the tolerances right within this analysis here. So, and I can save it as an analysis. I'll create multiple analysis, right? If I want to, just like your analysis features. So getting back to the presentation here. The last thing that I want to touch on real quick is BMX, or Behavioral Modeler Extension. So some of you may have known it, but what it really allows you to do is design optimization on analysis features. So anything that you can measure in Creo parametric. It could be center of gravity, it could be mass properties like weight, volume, it could be even surface area, right? Anything that you can measure, right? You're able to capture it as a parameter. As you know, in Creo, you can also create datums out of it, and you can also run some sensitivity and optimization studies. So you can have a goal telling that my center of gravity in my crankshaft, for example, should always be at the axis. I want Creo to help me in determining the counterweight, or, I know traditionally I've been there during my industry days. I had to do a lot of trial and error. You go back, change the design, right, rerun the analysis feature and see where it is, things like that. So that's something that you can automate using Behavioral Modeler Extension. To give an example of this golf club, right, so let's say I used Creo parametric to get my center of gravity location. However, I have a desired location, and how do I get there, right? There might be quite a few dimensions for that weighted insert that you see in the golf club. I'll have to play around with it vertically and horizontally, right? Where should this insert go, right? Should it go, there might be a dimension here. There could be a dimension horizontally. It could be here, or this could be here, or this could be here. So that's something, instead of doing it manually, right? First of all, let me show you how a manual process might look like. I'm sure you might have done this for your designs. It's a lot of design iterations, doing it manually and then evaluating your goal, right? So let's say in this case, I'm looking at a couple of dimensions, and I have a ratio for that, and I'm trying to change those vertical dimensions. And my design goal is to make sure my target center of gravity and my current center of gravity, right? The distance between those has to be, let's say, really, really very less, or it has to be almost the same. So I start off with an existing design, and I do a second iteration. You see how I reduce that a little bit. I started off with I did a third iteration. I'm just guessing on some values, right? Based on your experience, you might try that, right? You have a good, based on common sense, what you can change the Y value, X value. You could keep doing this, and it's very critical, here, the data that I have here, the amount of time that you take, right, to get to 0.05 from 0.37, right? And then there's a design change, and how do you redo this again and again? So that's what we want to help with Behavioral Modeler Extension, where, like I said earlier, anything that you can output in Creo, you're able to use that as a goal in BMX, and you can use it to optimize. So in this case, what I would do is I would calculate the distance, right? I would ask Creo to calculate the distance between the target and the actual COG, the center of gravity. And then what I'll have the software do is tell me what dimensions impact the CG location the most, the horizontal or the vertical or any other dimension, right? So I'm able to do sensitivity analysis between some known dimensions in Creo and the CG location. Once you figure out what are your most sensitive dimensions, then you could use it in an optimization study. So in this case, as you can see, there is my horizontal and vertical dimension. I would like to use it, and I know there's a minimum and maximum based on my design limits or manufacturing limits. I can assign that, and I can have the software do all the heavy lifting. You see where I'm going with this, right? You're not manually going back and changing it and then seeing where the CG is. You want the software to optimize it for you based on a number of iterations. So in quick time, you're able to do it. Now, this is simple geometry. In the real world, I'm sure you guys have much more complex geometry, and that's when you would see, it's a big, huge benefit of using BMX for optimization studies. Okay, so really quickly, if I were to open up this assembly, so there's my golf club assembly, and there's the insert I was talking about, right? I have a weighted insert, and that's the thing I'm using to control my CG, if you think about it, right? So currently, where's the CG? I have an analysis feature, right? So if I go redefine the analysis feature, whenever you do any analysis, you know that you can change to a feature and go into this feature tab, and you're able to turn on CG location, create a datum point automatically. Now, for this piece, you do need the BMX, right? It can output values, but you need the BMX to generate that coordinate system or point automatically. So that's what I've done here. So I have a datum point, right? There it is, right? So that's my CG datum point. So if I go to my point tags here, you can see that's my center of gravity point. Now, I also have an analysis feature where I've calculated the distance between the datum points. So in this case, I want to make sure the datum point, the distance between the plane and the point should be 0 or pretty, very, very close, very minimum, right? So that's what I want to make sure I don't do this manually, right? So you see how I have a distance parameter that I have between those. And I would like to use this distance parameter for my optimization study and sensitivity study. So now that I have BMX, I go to my analyses and I can do a sensitivity analysis where I essentially select my dimension, right? So let's say I'm going to select from the main component, I'm going to select a data point location where I have, that's controlling the location of that insert, right? And I can give it a limit. And the parameter to plot is the distance analysis, right? That from analysis 1, right, I have an output called distance, and I want to compute it. So what it's really doing as we speak right now is it's doing a sensitivity analysis and letting me know what would be the best value for that dimension. You see how quickly it did that compared to the typical manual process that you might have to do it, right, manually. So so there it is, right? So I'm looking at the minimum distance. It's pretty close here. That's what I should be using. But there's also vertical dimensions. So like this, I can do on a vertical dimension, horizontal dimension, and then on multiple dimensions. And then I can do an optimization study. And I could simply say, I want you to minimize the distance. Or I could simply say, I want you to make sure the distance should be, let's say, so much value. I'm setting a goal based on one of my analysis features. And I'm also giving dimensions, right? So I go to that point dimension that controls the location, right? And also I'm going to select, I do have a surface. I used the surface modeling to create this, but I have a vertical dimension, as you can see here. And I'm going to apply some limits on both these guys, right? So this could be some limits as a designer, as an engineer, you know some limits that you're working with. So I'm just giving that limit, the solution space essentially. And I'm having it compute it for me, right? So there it is, right? I have the two, and I hit compute. And what it's doing right now is it's doing its iterations as we speak, right? And it came up with a solution right there, right? So it's the first iteration, second iteration. So currently the distance is here, and now it has brought it pretty close, right? So my point is, you could really help automate your design iteration process using this particular BMX functionality. And I also have the option to simply change it, right, or keep the design. So if you remember, originally this insert was somewhere here, and now it automatically optimized it, and there's a new CG location that I wanted pretty close to the datum plane right there, right? So I had a datum plane there, and it was pretty close to that. So getting back to the presentation here. So that's, hopefully, you got a good overview on the different simulation tools in Creo. If you have any questions, please feel free to type in the chat or question session or section in your GoToWebinar window. All right, so it looks like there are no questions at this point. So just before we wrap up, just wanted to remind you all about the 3 offers, right, on the Creo Simulation Analysis Solutions running through June, through the end of June, as well as on the training and the PT Certified Training, virtual training. Also on the MatCat product, please reach out to your reps at TriStar if you need any additional information on these 3 offers. And please, if you could visit our website, and there's more information about the PTC LiveWorks, and our PLM team, our experts will be there to help you with any questions as well. Looks like there's one question here. I am new to simulation. Our product is linear motion devices. What type of analysis should I be doing? So yeah, okay, so when you have a linear motion device, I'm thinking you obviously have, you could make use of both Creo Simulate, which has sliding contact capability, right? The Advanced Simulate extension has that capability. Now, again, like I was showing you in my examples, for the motion side of it, where when you have a joint between 2 bodies, or when you have parts interacting with each other, it's very difficult to really get the forces, right? That's the challenge always in the real world, and that's when the mechanism dynamics option is going to help you to get those reaction forces and then export that into Creo Simulate or Advanced Simulate and run an analysis on it, right? So I'd say, I probably need more details about what exactly you're trying to analyze, but based on what you're telling me, it would be Advanced Simulate as well as MDO, so they both need to kind of work together so you can export the forces and then use those forces to run a simulate analysis. All right, so thanks again for your time. So we look forward to seeing you all soon in another webinar. So until then, have a great rest of the day and a great weekend ahead. And please let us know with any other topics or that you would like to see us do a webinar on. It could be on the PTC products like MatCat, Creo, or Windchill, right? So please let us know. And until then, thank you very much.